Gaskets, plugs, and seals can be printed using inkjets. Our ability to print rubber-like materials really sets us aside within the industry. We are the only player in the 3D printing space that can print real rubber-like materials of different shore levels. When it comes to testing seals, for instance, we can simulate the right shore level to match that seal, and in addition to that, using rubber-like materials allows for gaskets, plugs, and seals to be a commonly used application. And when it comes to using Connex technology, it becomes even more simple, because rather than print the seal apart from the desired product, why not just print the product together with the seal as one printed part? And that's what our customers are doing.
Rubbermaid is a major manufacturer of home and food storage containers. In their plastic container designs, they extensively use molded seals and gaskets. A gasket, or a mechanical seal, is a device which helps join systems or mechanisms together by preventing leakage, containing pressure, or excluding contamination. Designers today are working to reduce part counts in products in an effort to reduce manufacturing costs. The use of dual-shot injection molding allows a single part to have the functionality and features that traditionally required an assembly of several components. The ability to design and manufacture mechanical gaskets and seals into a single part is an example of this design trend being applied by Rubbermaid engineers. During the design of Rubbermaid's premier food storage containers featuring flex and seal lids, the Connex 3D printing machine was used for the prototyping. To prototype the new design via traditional methods using RTV molding would have taken approximately 10 days to produce functional parts, which could have potentially impacted the project schedule. By using digital materials to closely simulate the physical properties of the selected production materials, they managed to test fit, form, and function of the product. To print the lid, a Connex machine was loaded with Full Cure 720 and Tango Black Plus. The semi-transparent material Full Cure 720 was selected for the center portion of the lid to simulate the ridged tough tritium material. A digital material composite of Tango Black Plus and Full Cure 720 with a short A value of 85 was chosen to replicate the flexible gasket of the lid. The printed prototype lid was subjected to various testing. During the fit test, the printed seals of the lid fit correctly aligned to the sealing surfaces of the container. The flexible seal is capable of bending and stretching, then returning to its designed and printed shape. This quality of the digital material allowed for a tight seal to the base, just like the production material. While closing the container, one corner of the lid is lifted while the center of the lid is depressed to remove excess air to produce a better seal. The printed lid was able to withstand this test hundreds of times without ever breaking. The quality of the printed seal is good enough to hold water, which exceeded the expectation of the design engineers and gave them more confidence in the quality of the design. The prototype lids also allowed the stacking and storage features of the lids to be tested. The dimensional accuracy of the Connex 3D printer also allowed for functional testing of the snap feature found in the top and bottom of the lid design. These features allow the lids to stack and lock together as well as for the top of the lid to lock to the bottom of the container. To sum it up, the Rubbermaid story is an excellent example of the use of digital materials to create gaskets, plugs, and seals that resemble the end product fit, form, and functionality.